Hello everyone, this is an overview of findthatbit. It's a video content semantic similarity search, and it is based upon an example by Qdrant, who provide the vector database. What I'm going to show you is how to build a semantic search site. I'll just give an overview. I'm not going to go into every single detail, but I will focus on one particular aspect in a second. We'll also look at how to get the data, format into an array of Python dictionaries, split it into chunks, encode it. Then we'll install the vector database, or look at how to do that. Look at how to upsert batches. And what do we upsert? Upsert ID, embeddings, and payload. And then we use the client for doing our queries. If you want to follow along to a similar tutorial, I'm not going to reinvent the wheel, but qudrant.tech/documentation/tutorials/neural-search. So this is the overview which Qdrant inspired me with, should we say. Create simple neural search service. Probably the best thing to focus on is actually this diagram here. So you start off with a data set. Now, the difference between what I've done and their example is their example uses a ready-made data set. And in some ways, that's kind of half the battle, isn't it? I mean, once you've got the data, formatting it and doing the rest of it is kind of, I wouldn't say easy, but yeah, getting the data and getting the data in the right format is often half the battle. So get the data set, convert it into vectors, upload it to the collection. So one is transform the data. Transforming the data is also something which may be different for each project you do, but if you can get into kind of a routine of a similar method each time, then that's going to be make life a lot easier. Qdrant. So Qdrant is a vector database. If you didn't know already, if you haven't seen my recent couple of videos, what you want to do is then query it using the Qdrant API, which the client, which you can download and you can then use with Python. To make that visible, you need to just do a very quick FastAPI, which is basically the bit at the end, which you can then query from your HTML and JavaScript if you're not using Streamlit. So most examples you see on YouTube or tutorials anywhere will pretty much be like this. They'll be in Colab notebooks. They may use Streamlit, and they'll be using existing data sets from Kaggle. So the difference here is that I've actually gone off and gathered my own data, formatted it. I'm not going to go into all those details, partly because it might compromise me. So what does this actually do? What it does is it allows you to do a search based on the meaning. So rather than just searching on the keywords, let's see if we do, I know this already because I've tried it, Roman engineering, which might seem strange for a site with a Bitcoin logo on it, but bear with me. So if we do submit, and it returns me 5 results each time. I kept it to 5 just to kind of give you a few different variations. So we typed in Roman engineering, and if we do Control F for Roman, you'll see Roman actually appears in 4 of the results. But here it just finds engineering. So it's actually finding the keywords, but the main benefit of this is it's actually finding relevant results based upon the meaning. Let's try another one. So if we put in, this is my favorite example because it's really easy, but if we put in seaside, and then if we search for seaside, you'll see it's found 5 results which are all relevant, but it doesn't even actually mention the keyword. That is where semantic search is so good. So I wanted to Naples, blah, blah, blah. I wonder if it mentions. So yeah, it doesn't mention seaside, but I can see already it mentions beach. So it's clever enough to find results with beach in, even when you search for seaside. So hopefully that's quite clear. Features, I've used the all mini LM L6 V2 sentence transformer for this. You can go to Hugging Face. So Hugging Face is a free, it's like GitHub for models. That's how I understand it. That's me. And there's a begging message there for some sats or for some donations, because this site costs me money and I'm not making anything from it. And if you're generous and you want to donate, if you can donate, then that would help me, because that would then help me fund getting this turned into an app. Because at the moment, although it's kind of half responsive, it's not really great on a mobile. So yeah, if you could do that, that would be amazing. So yeah, carrying on with the simple neural search service. This is the Qdrant tutorial. So let me just go down to the bit I'm going to do a demo on. So you can follow all this. There's no point me just talking all the way through that. So yeah, run Qdrant Docker. That's the instructions for actually how to get the Qdrant database up and running. But before you do that, before you actually run the database, you need some data to put in it. So what I'm just going to quickly show you is this, which is a small piece of code just to demonstrate a concept. So right here, I've got 4 lines of, you see the curly braces, so it's like a Python dictionary. But often, either if you've built the data or if you've got it from another source, this is not actually a standard Python object, so it's not a list as such. It's just 4 dictionaries. So you can tell it's just 4 dictionaries because there's no square bracket at the start, and there's no comma just there. So what we've got is some kind of weird thing which is just 4 lines of dictionaries. So what we do is we use pandas. We do import pandas as PD, and then we use PD read underscore JSON. So that's what's doing a good bit for us, and then it's actually turning it into a data frame. So when you see dataset being mentioned, dataset is actually a Python object based on, I believe it's Arrow and Apache and so on. Don't worry about that. You can just use what I'm showing here, which is basically read in a whole array of dictionaries. I've just obviously just done the printed top 4 there. So if we run that, and then you just see that it's loaded into a data frame. Once it's in a data frame, this is where the bit I wanted to show you is. So don't worry about model and code, that'll throw an error in a minute. I didn't want to kind of overcomplicate this, but model encode is basically where you use the Hugging Face model to encode the data. But what we've got here is row text, and then for each row in the data frame, we're going to use itertuples. If you've not used itertuples before, go to the pandas documentation, and there are some examples. And if we go to the top, iterate over data frame rows as named tuples. You don't have to worry about them being named really. If we go to here, and then we just run this, and we've got that error because of the model encoding, but it has still actually run, and then it said data frame loaded, and it showed us the top 4 results. I think it should work if we do print vectors.shape. No, it won't, because model encode. Right, so model's not defined. Again, I don't want to cover the model here, but really what you need to use is for row in df itertuples. In fact, let me just get rid of that. And we could just do print row. There you see, that's given us, that's actually created a tuple for each of the, and it's going to be iterable. So what you need when you are doing the Qdrant tutorial is you need to end up with a bunch of, let me just zoom in on this. So for instance here you've got the payload, and you have to turn that into an iterator. So you're using map and you're loading the file data, mapping with JSON.loads. When you actually do the upsert, which is where is the upsert? That's the search at the end. I've gone too far. Yeah, so when you're uploading the data, vectors is a vector. So that's basically an iterable. The payload is an iterable, and the IDs it generates itself. So that's why we're using the itertuples. Best thing to do is have a practice with it. But that once you've the other thing which I've done, which they showed, was to actually do mp.save, and you can save that as a numpy array, and then you can bring it back in. So let's go here and numpy.save. So again, this is mp.save because I've done a short alias there, but the other thing is don't pickle it, but save an array to a binary file. So it puts it to one side, and you can then import it back in. So that's that. Let me just carry on with the rest of this. So once you've prepared your data, then you do the thing called the upsert. So again, they've done that there. Look, they've done what I've just showed you. df itertuples. The other thing they're doing is the show progress bar, which you need to import tqdm for that. So because they've imported the model, they then have they can do the vector shape. So you've then got 40474. This is their example. So they've got 40474 rows effectively with 384 columns, if you want to look at it that way. Very important to get the dimension right. So that's the dimension. When you create your vector database, you need to specify the number of dimensions. So again, you see 384 there. That must match. If it doesn't match, you get an error and it doesn't work. So one other tip here is use recreate collection if you're experimenting. So then it just deletes the database each time, or the collection, and then it recreates it. Once you've got a site kind of in production, you won't want to keep recreating the collection each time, because eventually you could have thousands or tens of thousands of results. So that's when you need to go and check the documentation for upsert. Further on, you'll find that upsert, here we're just doing an upload collection because it's running for the first time. Qdrant client.upload collection. What we would then be doing is, let me just go to my other code. You would then be doing upsert. So if I drag this across, I'll just show you my code. That's timed out, but client.upsert, and then you need to use something called points. Points is basically the overall bunch of, it's like the overall It's like a table almost. It's like the bunch of rows. So you've got your payload, your vectors. Let me just see if I can find. Let's just go here and we'll just find upsert or upload points. And I think this is something specific to Qdrant. Again, it's terminology. So yeah, points is basically a list. So here you just see there's one line, but if you want to pass in an iterable, you can. So what I did was I passed in an iterable of ID payload vector. So upload points. There's Python example. So they've got 3 IDs. The payload is 3 dictionaries, and the vectors is 3 lists. So that's upsert. So yeah, you need to use points. I'm not going to cover that here, partly because it's a whole topic in itself, and partly because I've not done it enough. So hopefully this has at least given you a taste for how to work with the data. So you will need to specify, you'll need to import a bunch of data from somewhere. You might even need to web scrape it. Probably best if you don't just use the Kaggle stuff, because say that's already formatted and then you're just copying someone else's. So try and get your own data. I learned a lot doing that rather than just doing the Kaggle data sets. If you're not interested in it and your job just involves setting up the models and doing the clever stuff, then ignore what I've just said. But what does this do, by the way? Yeah, so if you click on the thumbnail, it takes you to the video. And it takes you to the video of the exact place where the sentence happened. So what did the Romans do for us? This is actually, this one I know is the Lex Fridman one, which is about 4 hours long. So hopefully you can see the benefit of this. If you wanted to find where seaports was mentioned inside a 4-hour video, how would you do that normally? You'd probably have to watch it on 1.5 speed and kind of just, yeah, hope you kind of, I don't know, hope you got lucky with potluck, or keep going until you think the conversation is heading towards the subject. But if the whole video is talking about power, energy, engineering, seaports, how are you going to find the bit that's mentioning the Romans? I don't think you would. You would just have to probably watch a 4-hour video on 1.5 speed. So yeah, there we go. If I click on that, I'm not going to play it because I'll probably get into copyright problem. But you see it's loading the video, and in a second it will play it. There you go. So there we go. Thanks for watching. If you've got any questions, or if you'd like me to make a second video where I kind of explain the upserting of the points and the encoding the vectors, then I can do. But really, I'd encourage you to just go to the Qdrant site, because the great thing about these vector database companies such as Qdrant and Pinecone, they have plenty of tutorials, so you really don't need to sign up to a university or anywhere else. So yeah, just remember using sentence transformers if you're doing similarity search, or if you're doing neural search on text. Those are the installs: sentence transformers, NumPy, Pandas, TQDM. And yeah, just remember what I showed you, df.itertuples. And basically that encode all the startup descriptions, create an embedding vector for each. Internally, the encode function will split input into batches, which will significantly speed up the process. So that's kind of a new thing to get your head around as well, is the kind of batching, doing stuff in batches. And chunks. You'll need to kind of chunk up your text. So if you've loaded a big long text file, you need to kind of split that up into chunks. And I think what I did was, I don't know if it showed it in this tutorial, but I basically split up my text into 360 characters. And then once it got past 360, then it just appended that to a list. So yeah, it's all here. Thanks for watching, and I will be back soon.